Hello everyone, my name is Professor Swapnil S. Sudke of SND COE and Research Center EVLA of Department of Electrical Engineering. Today we will see the topic of the subject Advanced Microcontroller and Embedded System. In it we see the Unit 1, that is PIC architecture and embedded C. In this topic, first we will see the overview of the SIS and RISC architectures. In this topic, the first point is the what is SIS architecture. Then second point is the what is RISC architecture. Then the third point in this topic is the comparison of SIS and RISC architectures. Then the first point of this topic is the SIS architecture. The SIS stands for Complex Instruction Set Computer. The definition of SIS and its architectures. SIS are defined as a classification of microprocessor or microcontroller based CPU design that operates on large and complex instruction sets so as to execute various tasks using the least possible codes are called as SIS microprocessors or microcontrollers, and architectures formed by using the SIS technology are called as SIS architectures. It is based on more than one instruction per cycle of execution approach. Then the second point of this topic is the RISC architecture. RISC stands for Reduced Instruction Set Computer. Then definition of RISC and its architectures. RISC are defined as a classification of microprocessor or microcontroller based CPU design that operates on small, simple instruction sets and have simple addressing modes so as to execute various tasks in a faster way are called as RISC microprocessors or microcontrollers, and architectures formed by using RISC technology are called as RISC architectures. Then a RISC cycle, the RISC style instruction engages one word in memory. The execution of the RISC instructions are faster and take one clock cycle per instruction. Then the third point of this topic is the comparison between the SIS and RISC architectures. In this point, we will see the comparison points of the SIS architecture and RISC architecture. The first point is that the memory unit is present to implement the instructions in the SIS architecture, whereas there is no memory unit and register store data is not present in the RISC architecture. In second point, the SIS architectures are having the microprogramming unit, whereas the RISC architecture are having the complex design of compiler. The third point is the SIS architecture having the compiler design having very easy, whereas the compiler design is complex in the RISC architecture. Then The calculations are slower, but they are yet precise in the SIS architecture, whereas the RISC architecture performs the mathematical calculations faster. Then there is difficulty in the decoding in the SIS architecture, whereas decoding of its instructions is easier in the RISC architecture. Then instructions are complex, so it takes time in execution in the SIS architecture, whereas it is faster as its instructions are simple in the RISC architecture. The external memory mandatory requirement in the SIS architecture, whereas there is no external memory requirement in the RISC architecture. The pipelining is difficult to implement in the SIS architecture, whereas the pipelining is easy to implement in the RISC architecture. In the SIS architecture, their processors are often stalled, whereas in the RISC architectures, there is no stalling of processors normally. Then the next point in the SIS architecture is the code expansion is easier in the SIS architecture, whereas the expansion of code can be an issue in the RISC architecture. Then the SIS architecture utilizes more disk space, whereas the RISC architectures consumes less disk space. Then the examples include in the SIS architectures are VAX, PDP-11, Motorola 68K, and our desktop PCs. Whereas the examples of the RISC architectures include DEC Alpha, ARC, AMD 29K, Atmel AVR, Intel i860, Blackpin i960, Motorola 88,000, MIPS, PA RISC, Power, SPA RC, Super H, and ARM. Thank you.